everyone, welcome back to my channel. I'm Preeti. I'm a first year computer science and engineering student at Sri Venkateshwara College of Engineering, Bengaluru. Our today's video is about computer aided engineering drawing, that is CAD, and our today's objective is to address a problem concerning the projection of planes. So before solving the problem, let's have an introduction to CAD. CAD stands for Computer Aided Engineering Drawing. It is a term commonly used in the field of engineering to refer to the use of computer software to assist in the creation, modification, analysis, or optimization of engineering drawings. CAD software allows engineers and designers to create detailed drawings of components, assemblies, and systems in a digital format. CAD software typically includes tools for creating 2D and 3D drawings, as well as features for dimensioning, annotation, and visualization. These tools help engineers and designers to accurately represent their designs, communicate design intent, and detect errors or interferences early in the design process. Overall, CAD plays a crucial role in modern engineering by streamlining the design process, improving accuracy, and enabling collaboration among team members working on a project. Applications of CAD. The real-world applications of CAD are 3D printing, dental industry, architecture, building furniture, fashion, and automotive sector. The important points to be remembered are we have three different reference plane. They are horizontal plane HP, vertical plane VP, and side or profile plane, that is PP. The different views are front view FV projected on VP, top view TV projected on HP, and side view SV projected on BP. The different notations used are top view of a point A is denoted by A, top view of a line AB is denoted by AB, front view of a point A is denoted by A dash, and front view of a line AB is denoted by A dash B dash. Side view of a point A is denoted by A double dash, and side view of a line AB is denoted by A double dash B double dash. Projection of planes. Plane surface. A plane is a two-dimensional surface having length and breadth with negligible thickness. They are formed when any three non-collinear points are joined. Planes are bounded by straight or curved lines and may be either regular or an irregular. Regular plane surfaces are those in which all the sides are equal. Irregular plane surfaces are those in which the lengths of the sides are unequal. Positioning of a plane surface. A plane surface may be positioned in space with reference to the three principal planes of projection in any of the following positions. The first one is parallel to one of the principal planes and perpendicular to the other two. The second one is perpendicular to one of the principal planes and inclined to the other two. And the third one is inclined to the all three principal planes. Projections of a plane surface. A plane surface, when held parallel to a plane of projection, it will be perpendicular to the other two planes of projection. The view of the plane surface projected on the plane of projection to which it will be perpendicular will be a line called the line view of a plane surface. When the plane surface is held with its surface parallel to one of the planes of projection, the view of the plane surface projected on it will be in true shape because all the sides or the edges of the plane surface will be parallel to the plane of projection on which the plane surface is projected. When a plane surface is inclined to any of the plane of projection, the view of the plane surface projected on it will be its apparent shape. Now let's solve a problem related to projection of planes. And here is our question. A pentagonal lamina of edges 25 mm is resting on HP with one of its corners such that the edge opposite to this corner is 20 mm above HP and makes an angle of 45 degree with VP. Draw the top and front views of the plane lamina in this position. Determine the inclination of the lamina with HP. To solve this problem, first let's draw an XY line. Select line command and thickness 0.35 mm. draw an XY line, and using text command, let's name this as X and Y. The plane above the XY line is VP and the plane below the XY line is HP. First we have to draw a pentagon of 25 mm and it is resting on HP, so we have to draw below the XY line. Now to draw the pentagon, select line command of thickness 0.50 mm and give the length as 25 and the first angle is 0 degree. Place it below the XY line. Similarly, give the length as 25 and the angle is 72 because the inside angle for a pentagon is 108 degree and the system takes outside angle. 180 minus 108 is 72, so we are giving us 72 as the angle. And the third step, 25 as the length. Now 72 into 2, 25, 72 into 3, 25, 72, into 4. So here is our pentagon. The given pentagon is resting on HP with one of its corner, which means the given condition is corner condition. So we have to rotate the pentagon in such a way that the corner should be on the left side. Now go to select option, select the pentagon and go to rotate option, select one of its corner and the side opposite to the corner and it should be the midpoint. Now rotate the pentagon. Now let's move this pentagon. Select move option. Now using text command, let's name the points. Select text command and I'll name it as A, B, C and D, E. Now let's draw the projection lines using line command. Select line command of thickness 0.13 mm. So this is our front view and we have to make this line at 0.50 mm thickness. Now using text command, let's name the front view. This is A dash. Since we are observing from HP, B is visible but the point E is not visible, so we are naming it as B dash and in bracket we are naming this as E dash. Similarly, C is visible but D is not visible, so we are writing as C dash and in bracket D dash. So further question says that the pentagon is resting on HP with one of its corners such that the edge opposite to this corner is 20 mm above HP, which means now I have to draw a 20 mm line above XY line, that is above HP. So to draw a 20 mm line above XY line, I am using offset option. Now select the XY line and give the distance as 20 mm. And here is our 20 mm line above XY line, that is above HP. So now I'll select this distance and delete it. And using distance between command, I'll measure the distance at the left end. So we have mentioned the distance is the distance between XY line and the 20 mm line above XY line. And the next step is to measure the dimension of the front view, that is A dash to C dash D dash, and we are also measuring the dimension of A dash to B dash A dash. Using smart dimension, let's measure the dimension. So the dimension of A dash to C dash D dash is 38.47 and the dimension of A dash to B dash E dash is 14.69. So in the next step, select the arc by center point and take a reference point on the XY line. Give the radius as 38.47 and cut this line. Now to join these points, I am using line command. Select line command and join these points. Now go to arc by center point. Take the same point as reference and give the radius as 14.69 and cut this line. Now using text command, let's name this as A dash, B dash and in bracket E dash, and this is our C dash and in bracket D dash. Now using angle between command, let's check the inclination of the lamina with HP. Select the angle between command. So the angle is 31 degree. Let's zoom it out. So as you can see here, the angle is 31 degree. Let's use the quick command to fit into the previous space. This line should be a thick line. So to convert it into the thick line, let's select the select tool and select this line and give the thickness as 0.50 mm. So here we got the thick line. Now let's draw the projection lines using line command. Select line command of thickness 0.13 mm. Since A is present over here, let's draw this and join to the point A. Similarly, point B. And point E. Similarly, point C and D. Now using text command, let's name the intersection points. Select text command and this is our point A, B, C, D and this is E. Now to join these intersection points, we'll be using line command. So select line command of thickness 0.50 mm and join A to B, B to C and C to D, D to E and E to E. And the next part of the question says that it makes an angle of 45 degree with VP, which means we have to draw a 45 degree angle below the XY line that is in HP. Now to draw the 45 degree angle, select the line command and place it on the XY line. Give the angle as minus 45 degree because it lies below the XY line and extend it up to a convenient distance. We need this line as a thin line, so select this line and make it as thin line by giving the width as or thickness as 0.13 mm. Now using angle between command, let's mark the angle that's 45 degree. Go to select option and select the pentagon. After selecting the pentagon, go to Move option, select point D and place it on the 45-degree line. Now go to Rotate option, select point D and point C and rotate and place it on the 45-degree line. Now using the line command, let's draw the projection lines. Select line command of thickness 0.13 mm. Now using text command, let's name the points. This is our A dash and B dash, C dash, D dash, and this is E dash. Now to join these points, we'll be using line command. Select line command of thickness 0.50 mm and join A dash to B dash, B dash to C dash, C dash to D dash, and D dash to E dash, and E dash to A dash. The first part of the question was to draw the top and front views of the plane lamina. So we have completed drawing the top and front views of the plane lamina. And the next part of the question says that to determine the inclination of lamina with HB. So it is 31 degree. And using text command, let's write it down here. Now select text option. The inclination of the lamina with HB is 31, and to mark the degree, use the character map. The character map provides us many symbols. Now I copied the degree symbol, so to paste it near the 31, go to select option and paste it here. Now I am removing the unwanted characters. So here is our 31 along with the degree symbol. Since we have drawn many projection lines, it is difficult to identify the movement of projection lines. So arrow marks helps us in identification of movement of projection lines. Now to draw the arrow marks, we will be using leader command. Select the leader command. Since these projection lines are moving upward, draw the arrow mark in the upward direction. These projection lines are moving in a downward direction, so we have to draw the arrow mark in a downward direction. And these projection lines are moving towards right. These projection lines are moving towards up. And this line should be a thin line, so select this line and change the width or thickness as 0.13 mm. The problem is completed and our today's session ends here. Thank you for watching. Please do like and share the video.